Alright, how's it going, guys? Make sure if you have any questions on any of the homework, you are letting me know. That way I can help you with it. Otherwise, I will assume you know what is going on. So today, lesson 2, we're going to talk about intervals. So we're going to talk about expressing an interval in interval notation and finding the intersection and union of intervals. Alright, so when we talk about intervals, the subsets of real numbers on a number line, we call that an interval. There are several ways to represent intervals. Consider x is greater than 3. So I'll do the first couple examples with you guys. Interval notation. Make sure if you have greater than or less than, right, that's going to be a parenthesis. And this is talking about interval notation. If it's less than or equal to, greater than or equal to, that's going to be a bracket. Okay? So, interval notation. X is greater than 3. The easiest way to determine intervals are your start and end points. So if I say greater than 3, it means I'm starting at 3 and I'm going to positive infinity. So interval notation, this is a greater than sign, so that's a parenthesis. And then if I go to positive infinity, that's also going to be a parenthesis. Anytime you use an infinity sign, whether it be positive or negative, it's going to be a parenthesis. Set builder notation, it's pretty simple. You make your set, you say x such that, that's how you write it, x with a line. You say x is greater than 3, and then you'll end your set. Graphing's a little bit harder. Okay, the big thing is when you're graphing, if it's less than or greater than, it's an open circle. If it's greater than or equal to, less than or equal to, it's a closed circle. So in this case, I'm starting at 3, open circle, and I'm going to positive infinity. So I would shade because I want greater than 3. You can always ask yourself, is 2 greater than 3? No, so I don't want to shade that way. But is 4 greater than 3? Yes, so I shade that way. All right, so that's one example. Again, positive infinity looks like this. Negative infinity looks like this. Do not forget that if you use this in interval notation, and you might as well get used to that word because it's going to ask you a lot on Hawks to write in an interval notation, you're thinking parentheses or brackets. All right, but if it's positive or negative infinity, we always use a parenthesis. So again, I talked about starting at ending points. X is less than or equal to 2. If I say less than, okay, or equal to, I'm going to start at negative infinity. And I'm going to end on my number. Notice these just have one inequality sign, whereas the next example has 2. So pay close attention to that. If I say less than or equal to 2, interval notation, I'm going to start at negative infinity. I'm going to go to 2. I have to use a bracket this time because it's less than or equal to. Set builder notation, say x such that, and I just copy down my inequality. Those are pretty easy. When you graph it, I got to decide, do I use an open or closed circle? Well, in this case, it's a closed circle because it was less than or equal to, and I would shade to the left because I went to negative infinity. All right. Last example, again, something different here. There's 2 inequality signs. So my start would be the left at negative 5. My end would be at 2. So interval notation, negative 5 has less than or equal to, whereas 2 has just less than. So a negative 5 I use a bracket, 2 I use a parenthesis. Set builder notation, again, is pretty simple. When I graph it, you start at the left and I go to the right. The nice thing about this one is you don't have to have an arrow because if you have a start and an end point that's a number, you're going to shade in between. I used a closed circle on negative 5 because it's less than or equal to, an open circle on 2 because it was just less than. All right. The big thing on this, guys, I know a couple of other examples to be wary of. Just make sure you're shading the correct way. Other than that, it should be pretty simple. So that is very important to know how to graph because that'll help you with intersections and unions. The big thing with intersections and unions, intersection is an and statement. So it has to be in both parts. So it has to be in the first part and in the second part. Whereas union is an or statement. So it could be one or the other. So it's going to be everything included. So this first example, to do these, if they say A union B or A intersection B, I would graph what they give me. So set A, it goes from 2 to 7. They're both open circles because they're both parentheses. So that's what that means. Now if I want to go 3 to 10, I'm going to use a closed circle, an open circle, and shade in between. So again, if they ever give you a set of numbers like that, that's how you would graph it. Okay, now union means furthest left to furthest right as long as there are no gaps. So in this case, my furthest left would be 2, my furthest right would be 10. And you write it just how you see it. 2 is a parenthesis, 10 is also a parenthesis. If I see an intersection, however, all right, that means what they have in common. So where the overlap is. My overlap is from 3 to 7. Do you see that? This right here to this right here, because it's part of the black line and the red line. So I would say 3 bracket 7 parenthesis. So that's how you do union and intersection. So the next one, we're going to talk about this. Okay. Graph them both. I'm going to graph A in blue. So -1, closed circle to negative infinity. So I would shade to the left. I'm going to graph B in red. 3, closed circle to positive infinity. So again, union is everything they have in common. So furthest left to furthest right. Or not everything they have in common, but everything overall. So furthest left to furthest right. If there is a gap, this is how you write it. So I start from the furthest left, which would be negative infinity to -1. Then I would say union 3 to infinity. Now intersection, you're looking for overlap. Do the blue line and the red line ever overlap? Hopefully the answer is no. So you would say there is no answer. I put a 0 with a slash through it. That's how I write no answer. Okay. Guys, be careful on the Hawks. I'm just going to show you a couple more examples. I know it's not on the notes or anything like that. But what they like to do is they will say like 3, and they'll do this to you. One's open, one's closed. Okay? So union would be negative infinity to positive infinity. However, they're going to ask for intersection. Well, intersection, you think, oh, well, they have 3 in common. However, if it's an open circle, that means I do not include that number. So there would be no answer. Okay? I would write this down in my notes because you will see this. They'll also do this to you. They'll say 3, and it'll be a closed circle on both. Now, what's your intersection going to be? Your intersection is just the number 3. Because that's the only thing they have in common. But it only works if they're both closed circles. Okay, so just be careful of that. The last example I have talks about the real number system. Hopefully you have the symbols written down. So we have real, rational, irrational. I'm just going to write our flow chart down. So it says let A be Q and B be N. So hopefully you know that Q is rational and N is natural. Alright, so if they ever ask for the union, you take the set of numbers that is the furthest up. So natural is all the way down here at the bottom. Rational is pretty close to the top. So union, my answer would be the Q, the rational numbers. And I'm going to use a symbol. Now if they ask for intersection, you take the one that's the furthest down. So in this case, it would be natural numbers. So my answer would be N. Again, we did this in the last lesson. It's kind of tying it all together now. All right, so your homework is going to be this thing right here. I'll do the first one with you guys, and I want to talk about these last 2 columns. So interval notation, right? What's my starting point? Well, hopefully you say -2, comma, what's my ending point? 6. Set builder notation, these are pretty easy. Just copy it down. Okay, if I'm going to graph it, I start at -2, open circle. I end at 6, open circle. I would shade in between. Now this section right here, open, closed, or neither. In order for it to be open, both of your dots, or whatever your dot is, needs to be a open circle. So if I have one dot, if it's all open, then it's an open answer. If they're all closed, then the answer would be closed. If it's a mix, one's closed, one's open, it's neither. So just keep that in mind. All right. Bounded or unbounded? Bounded means it's going to end. Unbounded means it has an arrow in it. So in this case, if I shade in between, that would be bounded because it's going to start at -2 and end at 6. However, if you have an infinity sign, okay, that would be unbounded. So that's just something to keep in mind. All right, so let's do another one. Let's do like x is greater than 11. Okay, I would start at 11. We would go to positive infinity. Again, set builder notation. 11, open circle, I would shade to the right. Now, because it's just a single open circle, I would say it's open. However, if it's both closed or just one closed, I would say closed. If it's a mix, one's open, one's closed, that would be neither. Okay? Bounded or unbounded? Bounded means there's a start and end. Unbounded means it has infinity in it. So in this case, it goes to infinity. Whether it be positive or negative, that would be unbounded. All right, I want you guys to finish filling this out. It should be attached in the assignment page. If you have any questions, please send me an email and we can set up something to meet. All right, have a good day, guys.